So I hope you tried out the problem. So let's look at the problem, look at the ideas involved, and then decide what this particular session is about in terms of the subject matter. So the problem given to me was that there is a hexagon, a regular hexagon with the side as 10 units, and inside the triangle DEC a circle is inscribed. Find out the radius of this circle. So on the surface it might look like a hexagon problem, or if you can spot it quickly, this is essentially asking you about the in radius inside a particular triangle. So if you have followed the in radius journey, discussing the in radius and the connection with the area, this spotting would be quicker. Otherwise you might look at it as a hexagon problem and approach the problem from that direction. Either way, at this point in the journey, the ideas will all get mixed together, and they should be getting mixed together so that we can deploy any of them as a tool as and when needed. Of course, if I am thinking of the hexagon, my story actually starts a couple of steps back with the 90, 60, 30 triangle. This is 90 degrees, this is 60 degrees, this is 30 degrees. If this side is A, this side, the 60-degree side, is going to be A by 2, and this side is going to be root 3A by 2. Memorize these results after understanding where they came from and proving them, but we have already done that work, so I have this result with me, and this idea in turn gets applied in equilateral triangles. That means all angles are 60 degrees. The angle bisector is also the perpendicular, so I have a right angle triangle. This is 90 degrees, this is 60 degrees, and this one is 30 degrees because you bisected a 60-degree angle into two parts. So I have the same 90, 60, 30 story playing out. That means if this is A, this is going to be A by 2, and this is going to be root 3 by 2 into A. Same story, different layer of meaning and language. And the same idea gets played out in the hexagon. So a lot of this work we have done earlier, so you can think of that as revision. In case you haven't done it, in that case I'm assuming you're confident with problem solving and you can connect the ideas together. So I have a hexagon. I know all angles inside the hexagon are equal to each other, and all of them are equal to 120 degrees. That means this is equal to 120 degrees. I also know it's a regular hexagon. That means all sides are equal to each other. That means this is equal to this. So I drop an angle bisector. I know it, and I know it is also going to work like a median for the other side. So now if I think about this 120 degrees, this became 60 degrees, this became 60 degrees. The angle bisector is also the perpendicular on the other side. That means this angle is 90 degrees. That means this angle is 30 degrees. And this side was 10. This side was 10. That means I have A. I have the hypotenuse of the 90, 60, 30 story. So now if I want the 60 degree side, I can find it so simply by dividing this by 2, and I will get that as 5. And if I want this part of the story, it is going to be 5 root 3. Because to go from the 60 degree side to the 30 degree side, all you have to do is multiply by root 3. So 5 root 3. Same story plays out here. This is also 5 root 3. And if I look at the whole side, in that case it becomes 10 root 3. 5 root 3 plus 5 root 3, 10 root 3. This is just warm-up work. A lot of this was not needed if you have followed the whole syllabus, because when we were looking at the hexagon, we already looked at how if I have a hexagon of side A, this short diagonal is A root 3. If you can use it from memory and you understand it well, that would be even better. So because I know the side is 10, I can very quickly conclude that this side is going to be 10 root 3. So staying with the same story, just cleaned up the figure. So now I have a hexagon of side 10 units, a regular hexagon of side 10 units, and I have concluded that this EC is going to be 10 root 3. If you knew it already, great, because a lot of time would be saved. You straight away know if this side is A, this whole thing is going to be A root 3. So now we are thinking of this triangle, because now I have all three sides, I can think of the area. And the question is about the circle inside the triangle. That means I am thinking of the in radius. What is the connection of the in radius to the area? Radius in radius into semi-perimeter is the area of the triangle. Area I will be able to find out fairly easily. I have all three sides. I can use the Heron's formula, or I have the base and the perpendicular, which we just saw, or we'll look at it again. But area is not a problem for me. The radius is what I have to figure out. Semi-perimeter. What is the semi-perimeter? Perimeter divided by 2. So 10 plus 10 plus 10 root 3. So 20 plus 10 root 3 is your semi-perimeter. Divide this by 2. What do you get? 10 plus 5 root 3. So this is your semi-perimeter. And now think of the area of the triangle. Area of the triangle is going to be half base. What is your base? This is your base, say 10 root 3. Why? Because the perpendicular is very easy for you. This is the perpendicular and we figured out this as 5. Why is this 5? Because this is a 90, 60, 30 triangle. This side is the hypotenuse is A. The 60 degree side is going to be A by 2. So that way I figured out that this is 5. Or whatever way you figured it out. So this is my area. This becomes 5 root 3. Overall this gives me 25 root 3. And that's it. I'm almost done. I have the radius into the semi-perimeter. That is going to be 10 plus 5 root 3. That means the radius is going to be 25 root 3 divided by 10 plus 5 root 3. Again, you can take something common out, solve this out. But now, I'm not even bothered about the final answer because now I have the radius. The radius is equal to some number, whatever that number is, right? So essentially this story is about the hexagon. The hexagon story is about the 90, 60, 30 story. And if you connect all of them together with the in radius, this question is very easy. But if you are struggling with each small part, this question might be very difficult for you depending on your own circumstances. So this was our next story. In a triangle, the ratio of angles is given as 1:1:4. So call the angles 1x and 1x and 4x for a second. So the sum of all the angles is going to be 6x. And the sum of all the angles of a triangle, day 1, day 2 theory, is 180 degrees. That means x is equal to 30 degrees. That means one angle is 30 degrees, another angle is 30 degrees, and the third angle is 120 degrees. And because these two angles are equal to each other, I also know side AB is going to be side equal to side AC. So it becomes an isosceles triangle for me. So another opportunity to look at the 120-30-30 story or the 90-60-30 story. Why? Because once I have this story, once again it is an isosceles triangle. If I go for the angle bisector, it is also going to work like the perpendicular. I think this statement throughout the course has been repeated 50-55 times. That if there is an isosceles triangle, you go for the angle bisector, it will work like a perpendicular. That means this 120 degree angle will become 60 degrees, and I have a 30 degrees and I have a 90 degree too. That means, say if my side is A, this side is also going to be A. And if I go for and now if I think of this side, this is the 30 degree side in the 90-60-30 story. I have the hypotenuse as A. The 60 degree side is going to be A by 2, and this side is going to be root 3 by 2 into A. From here to here, you have to multiply root 3 by 2. From here to here, you have to multiply a simple root 3 because you've already multiplied a 1 by 2 earlier. So this part of the story is going to be root 3 by 2 into A. And remember, this angle bisector is not only perpendicular, it is also the median. That means this part is also going to be root 3 by 2 into A. If I add them up, what will I get? 2 root 3 by 2 into A. So I will get a root 3 into A. And if you notice this story, this is the same story as the hexagon because this was happening inside the hexagon. So with each problem, your ideas will get repeated hopefully so many number of times that you have both the skill and the expertise, because next time, because this is the third or the fourth time, the fifth time will be the lucky charm. The moment you see this, maybe you will not have to do all of this work and you come to this point quickly. And now I have the perimeter because the perimeter in the story was given to me. So A plus A plus A root 3, that means 2A plus A root 3 is equal to 2 plus root 3. If I take a common, 2 plus root 3 is what is left inside, and 2 plus root 3 here. This is getting cancelled, that means a is equal to 1. A is equal to 1. And this side, a root 3 is root 3. And so thinking of the area, half, this is the base, into root 3. I want the height, this is my height, this is a by 2, a is 1, so this would be 1 by 2. So into 1 by 2. Overall I get root 3 by 4 as my answer. So this is our next problem. Triangle ABC, AB and AC are both 25 and BC is given as 40. Furthermore, AD, BE and CF are angle bisectors and they meet at this point. We know this point is known as the incenter. And the question is, what is the length of AI? So we're looking at incenter, we are thinking of angle bisectors. So let us quickly revise a couple of properties related to it. Starting point is obviously if I have an angle bisector, if the sides are A, B, C, this third side will get divided in the ratio of the sides which create the angle. This is idea number 1. The other idea was that if I have multiple angle bisectors and they meet at some point, and this point is A, this point is I, and this point is D, the ratio AI is to ID. The sides are still the same. This side is A, this side is B, this side is C. The ratio AI is to ID is going to be B plus C. B plus C is to the third side, A. So add these two sides and compare it to the third side, and that is your ratio. And this is the property that we need for this particular story, because there is another one that the in radius into the semi perimeter will give you the area. There is another one about how much is this angle going to be compared to this angle. But this is the property that we need right now. So a quick revision and moving into this problem. That means I know the ratio of AI is to ID. If I want the ratio of AI is to ID, the ratio is going to be 25 plus 25, 50 is to 40. So I know the ratio is 5 is to 4. But I still need to find out the value of this whole thing so that I can apply the ratio and find this part of the story. So how will I go about that? And this we have done numerous number of times. Once again in isosceles triangle, angle bisector, this is the perpendicular. So I have a right angle triangle. Not only the perpendicular, it is also the bisector. That means if this was 40, this part is 20, this part is 20. This is 5 into 4, this is 5 into 5, this is going to be 5 into 3. I am applying the triplet here. So I know this, all of this is going to be 15. That means AI plus ID, the total is 15. So now can I find AI? Very, very easily. 5 by 9, because AI is 5 out of 9 and the total is 15. You can simplify this further. 3 3s are 9, 3 5s are 15. So 25 by 3. So a quick revision of this idea, that where the angle bisectors meet the incenter, it divides the angle bisector in a certain ratio. What is that ratio? The ratio is add these two sides and connect it to the third one. So this is our next problem. In the triangle ABC, AB is equal to AC, so it becomes an isosceles triangle. Furthermore, AD is the angle bisector for angle A, I is the incenter. And it is given to me that AI is to ID is 3 is to 1. In whatever language, this is the final result for me, that the ratio of AI is to ID is 3 is to 1. And I just looked at the property of how the incenter divides the given angle bisector in a certain ratio. So say if this side is X and this side is also X, because they are equal to each other, and the third side is Y. What do I know? X plus X, that is 2X, is to Y is the same as 3 is to 1, because we just looked at how if I have a triangle with sides A, B, C and I am thinking of the angle bisector and the incenter divides this angle bisector in the ratio C plus B is to A. So same property I am using here. X plus X is to Y. So I get 2X is to Y. So 2X upon Y is equal to 3 upon 1. And now I have a relationship between x and y. 2x is equal to 3y. So I can build the whole story in terms of y or in terms of x. Let's do it in terms of x. I can say y is equal to 2 by 3 of x. So if I go back to my triangle, this side is going to be 2 by 3 of x. And in fact, at this point, let me multiply all three sides with 3 to make my life easier. Let me call this 3x, this becomes 3x, and this will be 2x. So my calculation will work out easier and faster. And once again, this is an isosceles triangle. That means this is a perpendicular. Not only this is the perpendicular, it is also the bisector. That means BD is equal to DC. This is getting divided into two equal parts. So if I am saying the whole thing is 2x, this is going to be 1x and this is going to be 1x. Now use either of the triangles and figure out the length of AD, because you want to connect it to the area. I want to finally find the in radius, but that I will do fairly easily if I can get the area going. So I want to figure this out, and now I will use the Pythagoras theorem. So 3x square is going to be 9x square minus 1x square is going to be AD square, because AD square plus 1x square gives you 3x square. So 9x square minus 1x square will give you 8x square. So AD is going to be square root of this. So you will get x obviously, and 8 is 4 into 2. You can find the square root of 4 as 2. So this will become 2 root 2x. So I have the length of AD. AD is this whole thing is 2 root 2x. So now if I think of the area of this triangle, I have the base as well as the height. Let me find that out. Half, what is the base? 2x. What is the height? 2 into root 2 of x. And this area is equal to 72 root 2. So start working this out. You will figure out the value of x. This 2 gets cancelled. This 2 gets cancelled. This root 2 gets cancelled. So now you are left with x square, and this 2 will go to the other side, which will make this 36. So x is going to be equal to 6. So this side is 18 for you, this side is 18 for you, and this side is 12 for you. So now you have everything, because you wanted to find the in radius. The in radius can be found out by this relationship. Radius into the semi-perimeter is equal to the area of the triangle. Radius I don't have. Semi-perimeter now I have. 18 plus 18, 36 plus 12, 48. 48 divided by 2 gives you 24. You also have the area already, 72 root 2. So the radius is going to be 72 root 2 divided by 24. This gives you radius as 3 root 2. So a little bit of work and a lot of multiple properties being thrown into the story. You're also connecting the radius to the area. You're using half base into height. You're using the isosceles triangle, and you're also using that the in center divides the angle bisector in a particular ratio. So you will see, as you find difficult problems, the chances are that it's not difficult in toto. It is made up of a lot of smaller parts. So master these small parts, and the big problem is not going to be, it is still going to be lengthy, but it is not going to be conceptually difficult at least. So another CAT problem, what was unusual about this was obviously the long story format, but I hope you were able to convert the story into this form, that there is a triangle. You have two sides of the triangle as 50 and 10, and the overall area is given as 150 square units. And the question was about finding the side AB. So this is your final goal. You want to figure out AB. So how will we go about doing that? For starters, drop a perpendicular. Call it AD. Why? Because I have the area. I know area is base into height. I have gone for this orientation. You can run the same process using this as a story, drawing that perpendicular. Very similar logics will play out. So say I drop a perpendicular, and remember this is not an isosceles triangle. That means this is not an angle bisector. and this is not getting divided into two equal parts. So you know nothing, no such thing, only that you're thinking of this as the altitude or the height of the triangle. That means my area is going to be half base. What is the base? 50 into and into AD, the height. AD is equal to 150 square units. So work this out. 53 is a 150. This 2 goes over there. You get AD is equal to 6. So this becomes 6. Once I have these two sides, and because this is a right angle triangle, I can use the Pythagoras theorem and figure out this side. But again, before trying out the Pythagoras theorem, this 10 is 2 into 5, this 6 is 2 into 3. So this side is going to be 2 into 4, assuming that you're familiar and comfortable with using the Pythagorean triplets. Very, very simple idea, as we mentioned earlier, and it can save a lot of your time in such situations, at least, especially if you're lucky. So now you know AD to be 6, and you know this DC part to be 2 into 4, which is 8. T, that means this is 42. And this is what we wanted to find out. Isn't this the hypotenuse for this right angle triangle? Because if this is 90 degrees, this is also going to be 90 degrees. So now you have this triangle and you have the base and the height. So 42 square plus 6 square is equal to AB square. So AB is equal to square root of 42 square plus 6 square. So this part and this part I'm leaving up to you. Should not be too much of a challenge. And that's it. We have the answer. You want to figure out what is the exact answer, go figure out what is 42 square, add it to 6 square, and try and find the square root of the whole thing. Should not be more than a minute's worth of work, but leaving that part up to you, and rest of the story I'm done with.